In the last presentation we started the registers, and now we will see what are the different data formats available to us and also the classification of the registers. So first I will start with the data formats. Data can be entered in serial or parallel form. If this is my register, then in this register the data can be entered in serial form. By serial form I mean 1 bit at a time. By this I mean 1 bit at a time. And by parallel form I mean all the bits at a time, all bits at a time. So if this is the register, then in this the data can be entered like this. This is the serial form. The data is entered in a serial manner, and let us take one example. And let's say if I want to enter a 4-bit data 1011 in this register. So if I consider the serial manner, let's say this D is the data that I want to enter, then it will look something like this. Okay, this is 1011. This is what I want to enter. And in the same way, if I want to enter it in parallel form, then I have to enter it individually to all the 4 flip-flops. Okay, so this one is 1 and this is 0, this is 1 and then 1. This one is the parallel form and this one is the serial form. In this I am entering the data 1011 in serial, and here I am entering the data 1011 in parallel. So if you want to plot this in the timing diagram, then first we will have D3. D3 is 1. From here you can see D3 is the input to the flip-flop number 3. This is D2, D1 and D0. So D3 is high, so I will make it high. D2 you can see is low, so I will make it low. And D1 is high, so it will be high, and the same way D0 is high. So this is 1 0 1 1, and this is D1 D0. So this is a small introduction about the data formats available to us, and you can also extract the data, the stored data, in the serial or parallel form. If you want to extract the data in the serial form, then it will come out like this, and if you want to extract it or retrieve it in the parallel form, then it will come out like this. You are getting out the stored data. And also this serial form is called as the temporal code. The serial form is called as the temporal code, and the parallel form is called as the spatial code. Okay, so this is all about the data formats, and you will understand it more when you study the different types of registers available to us. And I'm just leaving the data formats here, and I will start with the classification of the registers. So let's start with it. Classification of registers. I will classify registers depending upon 2 things. The first one is the input and output. So I will classify it depending on input and output. This classification is very important. So let's see the first type of flip-flop available in this category. This is the SISO, SISO, serial input, serial output. You can see if I am entering the data in the serial form, then I will say it is serial input, and if I am getting out the data also in serial form, I will call it serial output. So in serial input, serial output register, we enter the data in serial manner and also extract the data in the serial manner. Very simple. That's why I explained you this data format, so that you can understand the classification a little bit easily. And the second one is the SIPO, SIPO, serial input and parallel output. You are entering the data in serial manner, but you are getting the data out in the parallel manner like this, and that register we call as the serial input, parallel output. The third one is the PISO, PISO. In this we enter the data in parallel form, parallel input like this, and we get the data out in the serial form like this. And the last one of course is PIPO, parallel input and parallel output. Simply we are entering the data in parallel and getting out the data in parallel. So this is the classification depending upon the input and output. We can also classify the registers depending upon the application. So depending on application. And we have two types of registers depending on the application. The first one is the shift registers, and this one is very important, very important. We will study it in detail. And the second one, the second type in this category is the storage register. So these are the two types depending upon the application. If you want your data to be shifted, like from F3 to F2, then F1, and then F0, and then comes out, we call it shift register. And if you want your data to be just stored, like you store the data and use it when you need, there is no shifting of data, the stored data, then we call it as the storage register. And in this way you can say that this PIPO, the parallel input parallel output register, is nothing but the storage register, because in this case we are entering the data. The one is entered in the D flip-flop, the flip-flop number 3, and this one that we have just entered is not shifting. It is there, so that's why it is just a storage register. In the same way, 0 1 1 is stored in flip-flop number 2, 1 and 0. There is no shifting of data, so it is simply storage register. It is a very simple concept, and actually the register is a very simple topic if you compare it with the counters or even flip-flop, because understanding the flip-flop initially from the combinational circuits is a little bit tough, and once you have the feeling of flip-flop you can easily understand these registers. So this is all about the data formats and classification of registers, and we have to study all these four registers in the coming presentations. And also we will study few special type of registers like bidirectional shift registers, universal shift registers, and in this way we will complete the register. So see you in the next presentation.